Okay, so this is a word problem, a quadratic word problem with an object getting launched at 19.6 meters per second from a 58.8 meter tall platform. So here's an equation that models its height after a certain amount of time, right? Notice the speed is there and the initial height is there, right? So we're going to use our graphing calculator to answer these following questions. So I'm going to need to enter this into my graphing calculator. I'm at y equals, and I'm going to put in negative 4.9, because really this s of t is like a y, right? And the t's are like x's. So I can just put in negative 4.9 x squared plus, oops, not down there, plus 19.6x plus 58.8. Okay, so I entered in the equation just with x's instead of t's. Now I need to pick a good window. Now a good window, this is not a good window for this, because if you think about it, how many seconds do you think this is going to be in the air for? I mean, not negative seconds, so I really don't need to see much more than 0 for the smallest amount of time. And maybe 10 seconds. I might try up to 15 seconds just in case. We can change the window if we need. But now y is about heights. What's the smallest height I'm going to see? What's the largest? The smallest height is 0, right, when it hits the ground. But I might want to see just a little bit below so I can kind of see when it does that. But it starts out at 58.8 and it's going to go up from there. So I'm going to go ahead and maybe guess 75 is the highest. That's just a guess, but we'll see. But now that I picked a window, we'll graph and see if it's a good window. Oh, notice I didn't get as high as I need to go. So I need to go back to my window and change it. So I need to go higher, maybe 100. Let's see if that covers it. Okay, yep. So notice what happened. The object went up. It got to the highest point and then it came down and hit the ground, right? So what is the maximum height of the object? Now remember, you can trace it to kind of see. Right now our x is at 7.5, so our cursor's off the screen and we need to get back over this way. So I'm going to hit my left arrow button. So I can trace it to kind of get an approximate answer here. It looks like maybe 78.3, 78.4. So right in here, my maximum height's around 78, right? Now if I wanted to be more accurate, I could do second calc. I could find my maximum. It says left bound, so go to the left side. It says right bound, so go to the right side of that maximum. And then it says guess, so go right to where you think it is and hit enter. And 78.4, right? So the maximum height of the object is 78.4 meters, right? When does it reach the maximum height? It looks like at around 2 seconds, right? It reaches, so this is the height, this is the time. So 2 seconds. After 2 seconds, it reaches its maximum height. Now, how long does it take before the object hits the ground? So that's kind of looking down here, right? So we'll trace again. But we got to look down here. So right around, it looks like 6 seconds. Here it's above the ground, here it's below the ground, right? So right around 6 seconds. So I could say around 6 seconds. If I wanted to double check that information, I could go to the table to see, right? In the table, notice that here it's at 58, then it goes up to 73, 78, 73, 58, 34, and then here down, yep, sure enough, it hits the ground at 6 seconds, okay? So now I can use my graphing calculator to draw an accurate sketch of the graph. So be sure to label my axes. So you guys, I don't need to put the origin right in the middle. Most of the important stuff of my graph is happening in the first quadrant, okay? This is time in seconds, right? This is height in meters, okay? And we want to get an accurate sketch. So notice here, you guys, it starts out at 58.8. It goes all the way up to 78. So I'm going to try to get up to, I'm going to try to get from here to here all the way up to like 80, right? So let's see, if I went by 10, 20, 30, 40, 50, 60, 70, 80, that'd be pretty good. So I can go by 10. And then here I'd go by 1, 2, 3, 4, 5, 6, 7, 8, right? And remember, we already know that it hits the ground at 60. And we know that it starts out at 58.8, remember? This right here is your y-intercept. So I'm going to estimate 58.8, that's right around there. And then here, we know where the maximum is. At 2 seconds, it reaches a height of 78.4. So at 2 seconds, it's going to get up to about 78.4 right there, right? At 2 seconds, 78.4. So now with these 3 points, you can get a pretty accurate sketch of the graph, right? You can, if your major important points are accurately sketched on the graph and the general shape, we got concave down because you got a negative coefficient in A, right? You got it starting out at 58.8, got it reaching its max there. Okay, so that's how to draw an accurate sketch of the graph.